Okay, well, hello everybody. Sorry about the alarm problem that ended us prematurely. So I'm going to pick up basically where I was at before. I pulled up, we had already talked through all of these, but just as a reminder, here is our setup, right? So top, we're actually have been walking through my test, but we'd already talked about how to build each one of these. All of this is basically set up besides the nut creation in this my test package. Um, so we had already walked through the agent, right? That's on these. So I believe we had just done the setting up the driver sequence item, to the sequencer port. I don't think I had explained that one. That's really just talking on this part right here. So the sequencer itself has one to send a transaction and the driver has one to receive it. So that's what this arrow is supposed to be showing. And that's basically what's being set up here, right? The driver's port from the sequence item to get its sequential items connected to the sequencer's export port. So that's pretty straightforward. Now, during the run phase, again, we could, for my agent, right? The agent's going to be able to send stuff and whatever. So the run phase, we have to have time delays potentially in it. So we take this task. It has to be a task for the delays. We get the run phase. And so to that phase that it passed to us, we raise an objection for ourselves. We're like, hey, we're doing something here. And then we'll drop the objection. Now, notice begin end. This is not part of this phase thing. Begin end can be used at any time we want to group things together. We usually don't worry about this, but technically speaking, there is a difference when I put this around. By putting a begin end around, all three of these are linked together. And they can run in parallel, but they cannot run in parallel to something after it. So by grouping these, I'm forcing all of these to run and finish before you get to this drop objection. So you really do need this begin end here. It's got to be after this the raise objection has to happen first. The drop objection has to happen when it's done. And then all we do is the my sequence that I built, that's a sequencer. I make my sequence to it, and for that, right? So this makes a sequence, and this then creates the one for it, and then this one passes it into my sequencer that's up here. So, start that sequence, and away we go. So this whole thing just sets that up. The particular details will be handled for generating the sequence over here, but this one just kind of says, build all this stuff for me. That's going to be the sequence. Now, as long as I've mentioned it here, even though we're not done these, I just want to jump over and kind of answer what's going on here. Some of this will be handled in the driver area too, but this one for the class my transaction, that's on, right? So this is going to handle a normal sequence item. So when we're doing this, where these sequences are made up of transactions, right? A particular, so we're going to stick this again into the object utilities. Awesome. Excuse me. Then we're going to say, how do I get those ones? Now, a particular transaction has a command and address and data, and we are going to generate these with RANDs. Every time you ask to build them, away they go. Now, this is a single bit, so there's no constraints. But this is an int. It could be potentially huge. So we set constraints on the address. You could literally put any name you want here. Right? This could have been constraint Fred and constraint Wilma. That by naming them things that relate to these, it just makes it easier for us to find. What actually specifies the constraint on address is what happens in the curly brackets. I can have a whole bunch of constraints, semicolon, basically for each individual one, and this one, I'm going to make sure the address is bigger than equal to 0, but it's less than 256. So that just sets it to its 8-bit number. All right, similar for data. Both of these I want as 8-bit numbers. So these ones work together. All right. This one, of course, just does that same deal with basic construction. Use the built-in one, essentially, is all we're saying. And that ends, what do we mean by a transaction? A sequence, right, is going to be, right, remember the UVM sequence is a templated class in essence, and the template that we're using is this my transaction that we've just modified that now has information about how to randomly generate it with the important third C of constraints. So the sequence, again, we've got to, send it up to the object utilities. Basic constructor, use the default. This is when the actual, what do we do inside this, right? We're going to make 8 of these, right? So we're going to have a request, which will be a transaction, right? It'll start it. If it doesn't, so this is building it. And if that request.randomize fails, so there are some simulators that cannot use randomize. They use the old urandom. So we're checking to make sure, are you able to run randomize? Do you have a system that can? For instance, Model Sim, which is actually a really good simulator. I like it a lot. It's got a lot of neat features, but it still uses the traditional random number generator. It doesn't do urandom. So to do this same thing, you'd have to change stuff around using urandom, the address urandom, and I can do a range, which does those constraints. There are ways to do it, but you just can't use the same sequence. So here we're just saying, if it doesn't have that, we're just going to tell you it doesn't work and you deal with it. So for this one, we're going to do 8 of these where it'll basically go, make them as needed, basically for them, build each one in turn. We'll finish up the item and away we go. We just make sure it generated them correctly. So this one, right, we have task. This is just specifying. It makes it easy to follow it by the named one. And then, of course, this ends for the my sequence. And you notice these colons, again, allow us to properly identify the classes that were being built, so it makes it easier to follow and read. It is something I think is a good idea to do. All right. Anyway, that's what's happening. So when we're doing this sequence and we're telling them to make them in that, it's basically going to walk through that and set up all my data for them. Now I've got my sequence, and we're telling the sequencer that, here's what you need, and away we go. And then once it has done that, right, since they're all grouped together, it'll finish all the stuff. Once it's finished everything, you can drop the objections. We've done everything. All right. There's 2 more ones here, right? My environment, my test. You'll notice it's really small and simple, so I'm not going to do too much. You've seen this already. We've got our component utilities, right? Inside the environment, we build the agent, which we just defined. So now we're using it, right? Using the standard constructor setup from the extension area, right? In the build phase, of course, we've got to worry about, basically passing all that data necessary to set up. Away we go. That's all we need, right? We're not doing anything else in the environment other than making the agent. So this is basically this setup area. So all it has to do is build that. Same thing, test is also going to be really short like this. Right? It extends test. There'll be one extra thing in here, but that's, not too complicated. So the actual test, again, it's going to make an environment. Right? It extended the UVM test, just use its standard builder. In the build phase, there you go, environment, and register it all up. In run phase, right? This is actually the one extra thing we're doing here is the whole purpose and where this thing gets its name. All we want to do is print, and we're picking the warning, so it'll be a different color. And we're just going to, wait 10 time units. So we had to raise an objection so that we actually get to finish, because if it ends before then, nothing happens. We're going to have to drop the objection. Since there's only one thing that we're doing, this will not end before this has. So we don't have to worry about this running on. We're just sending a single warning message to them that says hello world. Right? So then that class and the package can end. Right? So these ones are very simple. The addition here just prints our hello world on the command line. We've already talked about sequence. Let's just talk about driver, which was part of the agent. All right, standard stuff. Extends, right? Here's my component utilities, right? Away we go, right? We have to now have a virtual interface based off this dot interface. Use the standard builder in build phase. Now we've got this virtual one. Now we got to plug it all together, or build the stuff to plug it together. I should say populate it, right? So when we do this, we've got, we're going to check to see if, right, not this database, right? So we're going to go to the database. We want to get this, right? If that does not happen, throw an error, right? If it does happen, this get function will get it and handle this. And it won't do the then case, so it just drops out and it properly built the content, right? This is the kind of the holder for it, and now we're going out to get the actual virtual interface, which connects to this particular one that's plugged into my device under test. So now I've got my handle to it, and this is now properly set with a handle. So technically this just makes a correctly built .interface, but that's virtual, but it doesn't connect it to the right one. So this get is doing that, and if it doesn't, it throws an error. Yay, right? Now the actual run phase. So the driver will get sequences. It has to ask, give me a sequence, pass it over. Give me another sequence, pass it over. So in the run phase, that's what it's going to do. Now, since its agent has already raised the flag, and this is a forever. You don't know how many sequences are out there. This is why you're not going to raise the objection here. This forever loop will never reach the end. So it has to be killable when it's done doing stuff. But the agent that we built that actually has the one that raised the objection does see both of these. So it can see when the sequence is dried up. When the sequence is dried up, it'll say, okay, I'm done, and this will get killed. So this forever will be ended. So that's why you don't raise an objection here. Please do not, otherwise your simulation will never end. So the virtual interface, we reset, we wait for a positive edge of the clock, wait one more time unit. After that positive edge of the clock, and we turn the reset off. This is kind of your standard. Now, technically speaking, we should do this in the reset phase. But if you notice, they're doing essentially the same thing I did in the previous class, where I'm centering my reset over that positive edge of the clock. Anything that's going to include these timing commands must be inside of a task. And then this is our drive traffic. Again, we don't know how many of them, so we put it in a forever loop. Right? We go to the sequence item port and we say, give me a particular request I'm going to send out. And then the virtual interface command gets the request command, blah, 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 right? So this is one of, in essence, the individual sequences we're sending out, right? You get the full set of the data. We wait for the positive edge of the clock. At that point, all this data has been read in, it's been answered to. So then we can say, okay, I'm done with this item, which will then allow me to now go back up and grab the next item, and there'll be a new item waiting. If you don't do this, it won't grab a new item. right? So you have to tell them I'm done with this one, then you can grab the new item. So that's basically how you read it. This does the pin wiggling, and that does the wait to make sure you're done. And it's been acted on. That's it. That's the whole kit and caboodle to it. When you are doing this, one thing under tools and simulators, just stick with the standard stuff up here. Stick with the standard simulator. This one does a nice job. All the rest of that. The only thing you're going to want to do is add this open the wave. Remember, over here in the test bench, we dumped this. This will open that up so you can look at it when it's done. So let's just run this. Doop, 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 doop. Here it goes. Now it's passing messages. If you're really fast, you might actually notice the particular messages we set up going by. I'm just going to scroll back to them when we're done. Then it pulls up the waveform. You can see our clock moving at nice paces. You can see the address, and it's grabbing them one at a time per area, right? It resets at the positive edge of the clock. Next one. So you can see that my driver is driving them. The sequencer is passing the sequences, right? You can see it's getting a whole bunch of different random numbers from all over the place. You can see the reset coming through just after that first one. If I ended early, I don't want to have a really short time. It might not be able to respond in time to it. So that's why that reset was there. But then we just see the normal read, respond to the clock, and you can see the system is indeed doing what it's supposed to do. Yay, the waveform looks lovely. Right? If we come back here, we can actually come in, and this is giving us that final report. Remember those end stages when it's going to report things? They gave us 11 infos, 1 warning. That's our hello world. There was no errors and no fatals. So then you're going to see all these infos, right? I received. So you're going to get all these, the different ones we got. 10 time units in, you can see our warning, hello world, right? And then there's some extra ones, right? Like I'm running my test, which wasn't one of the ones sent by this, but it's still handled, right? There's these 3 extra ones telling you test done and things like that. Right, getting ready for the extract phase. Yay. That's where we get all this data from. So this will give you a nice summary, and then you can look up what you care about. And so you can see here and go, oh, no errors or fatals. There was a warning. Oh, what was my warning? Hello. So that's basically it. If you wanted to be able to modify to do them, again, remember, if I wanted to turn this into like some type of adder, checker, or whatever, you could implement in here something that does addition and change this. You'd also have to change it. Maybe make this like instead of address and data, maybe make this A and B as your inputs. That's out there. And your command could be like add, subtract, meaning. And so in here, you could do that. That would be a fine way to do it. Then you're just going to have to make sure in your sequence that you define those sequences to be correct. You'd have to change this to your A, B's and that. But that's, if you notice, that's really what you need to change. You know, what are the constraints to generate them? After here, this is all generic, right? None of this has particular information about the details, right? You just need to change them here. The driver, right? Aside from this, right here, you have to tell it how to change the pin wiggles because you changed the virtual interface. That's a pretty simple change to make. But aside from that, it doesn't really matter, does it? Right? And if you look at all these other ones, it really does not, other than like we have this hello world in here, you may want to remove that. But other than that, there's not anything that's specific to those data in here. This sets up all the stuff that does the machinery behind the scenes to handle this for you, which makes it really nice to be able to handle. There's also nothing up here really that's getting particular other than our clock build that's out there. All right, but you probably still want to keep that clock build anyway on your interface for time sequencing. Anyway, that gives you an idea, and again, how you can modify it, right? Modifying up here, modify your driver for pin wiggling, and modify your design. And you can set up different ones, and away you go. All right, well, hopefully this helped and makes up for the end of the class. And have a lovely weekend.